Right, children, this morning in our mental and oral spot, we are going to be looking at reading scales. Now, on my board here, I teach Y6 and I've been using the interactive whiteboard for about 2 terms, mainly in the teaching of mathematics, but also I have used it in some of the science lessons. Initially, I was a bit daunted at the prospect of having an interactive whiteboard in my classroom. I'm not the most confident person when using ICT, but with a little bit of training, I was quite surprised at how quickly I was able to incorporate that into my lesson plans. Now, when we're reading scales, the most important thing to do is to look at the interval. What is the value of each interval on this cylinder? Joe?
2.
2 millilitres, good boy. Joe, why is it 2?
Because for every 10 millilitres there's 5 marks.
Okay, I'm going to change the scale now. In the mental and oral starter, I was able to demonstrate different size cylinders very, very quickly and swap from one scale to another. And I was also able to model children's thinking skills, the mental calculations that they were trying to do when they were trying to find the difference between 2 numbers. Hattie, would you like to come and put 330 millilitres of fluid in our cylinder for me, please? And first of all, I want you to put the red marker where you think it should be.
Okay.
Okay?
I'm going to press this red marker so I can read where I need to put the fluid in into the 30.
Good girl.
So I need to put 1, 2, 3 in the 3 in the hundreds column and 3 in the tens column, and then fill it up.
See if she's right. Excellent. The interactive whiteboard has also helped me save time on making resources. So for example, if I'm using arrow cards, if I'm using measures, graphs, whatever, it's all there for me. I'm going to move my marker this time, but I'm moving it all the way up here. But I want you to do 2 things on your whiteboard. First of all, I want you to work out the answer. Tell me how much fluid I need to put in there so that the level of fluid would be equal to my marker. But I also want you to note down on your whiteboards how you got your answer. Now, first of all, can you tell me where we were trying to get to?
420 millilitres.
Right, and what did you think the difference was?
250.
250. Did everybody else think it was 250? Yes. Anybody not think it was 250? Oh, well done. Okay, I want you to take the pen. I want you to bring the red marker down to where we started at 170, and I want you to model how you got your answer.
I'll bring it down to 170, then I'll add 30 to make 200, then another 200 to make 400, then a 20 to make 420.
That's correct. Should we let her fill it? See if you were all right?
Yeah.
Put 250 millilitres in and see if you're right. Because if Tina's right, you're all right, since you'd got 250 millilitres. Are we right? Well done. Using an interactive whiteboard has helped me teach mathematics because it's a really good, strong visual aid. I've been able to demonstrate, model, and children have been able to grasp the concepts a lot quicker.
60.
Good. The interactive whiteboard also helps those children who perhaps have a shorter concentration span. It's more exciting and it just somehow helps them to concentrate on the learning objective. For the main part of our lesson, children, we're going to look at patterns in numbers and developing our reasoning skills. Now, on the board here, I'm going to highlight some numbers. And can you see that I've highlighted all the prime numbers between 1 and 20? What are you shaking your head for?
Because you've highlighted 15 and 9.
So?
They're not prime numbers.
Why not?
Because prime number can only be divided by itself and 1.
So Joe, what you're telling me is that prime numbers are divisible by 1 and itself.
Yeah.
So I'm going to change 9 and 15 because Joe rightly said that they are not prime numbers. So I've got it right now. Ellie?
No, because 1 isn't a prime number.
Why isn't 1 a prime number?
It doesn't have 2 different numbers that it can be divided by.
So I'll have to take it off then, won't I? Yeah. Okay. So, third time lucky. Am I right? Yes? No? Yes. Okay. Now we're going to continue. 23. Is it a prime number, Rachel?
Yes, it is.
Now I want you to justify that. If I have to ask you to justify how you know that's a prime number, you're going to have to use tests of divisibility to prove to me that that number's prime. Now, what is the smallest number? We're going to look at how we do that. What is the smallest number that you'd have to check first? Simon?
2.
2. Is that number divisible by 2?
No,
Why not?
because it's an odd number.
23 is an odd number. Tell me something about 2.
It's an even number that can only go into even numbers.
Well done. So it would leave a remainder if it was going into 23.
Yeah.
Do we have to keep checking any more even numbers? Neil?
No, because they'll only go into even numbers.
Without, otherwise there's a remainder. Well done. Okay, so we've done 2. What about 3? Is 23 divisible by 3? Hattie?
No.
Why not?
Is it because 23 isn't in the 3 times table?
That's right. 23 isn't a multiple of 3. Is there another test of divisibility that we can do when we're talking about 3, as well as saying, is it in the 3 times table?
If you add the 2 digits together, if they make a number that's divisible by 3, then that number will be divisible by 3.
So that's another clever way of seeing if a number is a multiple of 3. And if we look at 23, which is the number we're talking about, if you separate the digits in that number, what does 3 and 2 add up to?
5.
5. So is 5 a multiple of 3?
No.
Alex, how far do I have to keep checking before I'm sure that there are no numbers that will divide into 23?
Till you get up to 10.
10. Rebecca, Alex says 10. Do you agree with that?
No.
Why do I not need to check 12? Jenny?
Because if you double it, it makes 24, which is higher than 23.
Excellent. So the only other number after 9, the only other numbers I have to check are
9, 10 and 11.
9 and 10 and 11. OK, we've checked 9. Do either 10 or 11 go into 23?
No.
Alex, do you understand that now?
Yeah.
So, if I was checking, say, 25, how far would I have to go in order to ensure that I'd done that test of divisibility?
13.
And why is it 13?
Because half of 25 is 12.
Right, children, we've got all the primes highlighted to 100. Now what I want you to do is look at the pattern on the grid where there are no prime numbers. You can see we've got no primes in the 4th column, the 6th, the 8th and the 10th. Tina, why haven't we got any primes in the 6th column?
Because the numbers always end in 6 and 6 is even.
Why do they always end in 6?
Because you're adding 10 each time.
Now we're going to record that pattern on a chart. So here on our chart we've got different size grids and we've got to record the columns with no primes. What can we now record, Pablo, that we've just done for the 10th grid?
10.
10, good. Anything else? Let's go back to the grid. So you've said there's no primes there. Where else can you see no primes?
8th and the 6th and the 4th.
Excellent. Let's go back. So we can put 4, 6, 8. Now, children, what you're going to do, we found the pattern for the 10th column. What you're now going to do in your group work is on your tables, you've got different size grids for you to investigate. And what I want you to do is look at those grids and see if the pattern changes. And you're recording the columns with no primes. For example, if I went to a 9 grid, an 8 grid, a 7 grid, whatever the size grid, does the pattern change? What you're looking for is to identify for me where there will be no prime numbers on the grid that you're working on. And then record those patterns on the sheet here that again you've got on your table, which is exactly the same as we've got on the board here. And you don't have to worry about the prime numbers because we've already found those and I'm leaving those up on the board to help you. Okay, everybody ready? Yes. Off you go. What do you think we're going to have to do first?
Fill in the rest of the numbers.
Right, well if you think in Y6 I'm going to let you sit here and fill in all the numbers, I don't think so. Which columns do I not need to check?
3, 5 and 7.
Right, 3, 5 and 7. Want to check on the board? You're right. Any other number that I don't have to check?
2.
2, why not?
Because 2 is a prime number.
Right, so instead of having to fill in all the numbers, let's take the columns down and see if we can find any prime numbers. 9 add 1, 10. What would the next number be?
19.
And what do we know about 19?
19 is a prime number.
So do I need to check that column any further?
No.
No. Don't need to check 2 because we've already said 2's prime. 3's prime. What about 4? What will the next number be, Rebecca?
13.
Do I need to check any further? No, because what do we know about 13? It's a prime number. So we can cross that one out and cross that one out. We don't need to check that one. What about 6?
6 plus 9 is 15.
15. What will the next number be, Olga?
24.
24. So what are all the other numbers there going to be? Multiple 3. So do you think we're going to find any prime numbers in that column?
They're not prime numbers.
We know there are going to be no prime numbers in that column. Well done. 7 we said we don't need to check. What about 8? 8 add 9?
17.
What do we know about 17?
It's prime number.
So do we need to check any further?
No.
No? And what about this column, 9? Am I going to find any prime numbers in that column?
No, because when you add the 9 and the 9, it's 18 and you don't get a prime number.
Excellent. Could you record that on your chart?
Yeah.
Okay. Now what I want you to do is I'm going to go away now and I want you to investigate the 11 grid in exactly the same way. No filling numbers in, all right, using the same reasoning that we've just done with the 9 grid for the 11. In today's lesson, I think the interactive whiteboard was most effective to help children who perhaps weren't seeing the pattern in the primes. I was able to go back and flip between the 100 grid and the chart, and certain children actually then were able to see the pattern where they may not have been had I not had that facility to use. Can anybody see some sort of rule happening here? Because I've got all of these odd numbers, 3, 5, 7, 9, 11, and yet 9 doesn't follow the pattern. What's happening here? Rachel?
Well, if the number's a prime number, then there'll be no columns without prime numbers.
Right, shall we put this to the test? If Rachel's right, if the column of the grid corresponds to a prime number, there will be no columns without primes in them. How could I check that on the board? What do I need to go to see if you're right? Alex?
13.
Should we do that? So if I go to 13 column grid, what do you think you will see?
Columns with prime, all the columns will have prime numbers in.
Are you sure?
Yeah.
You positive?
Yeah.
Shall I put one up and see if you're right?
Okay.
Okay. Let's see if we're right. Let's see if Rachel's got a rule for us here. So let's go back here. We're on a 9.
10, 11, 12.
You ready?
13.
Have we got a rule?
Yeah.
Well done. We've tested the 13. What's the next sized grid where Rachel's rule will apply? Rosie,
Will it be 17?
you tell me, will it be?
Yes.
Why?
Because,
What do you know about 17?
Because 17 is a prime number.
What will the next size grid be, Danny?
19.
19 then?
23.
So after 23, what's the next one going to be? Leanna?
29.
Good girl. What about 77? Will there be columns that have no prime numbers on a 77 column grid?
Yes.
Excellent.